Welcome everybody to our division with polynomials lecture. And we're going to do a couple of different kinds of divisions here. The first one we're going to talk about is dividing by a monomial. All right. And this is the simplest of the divisions we're going to talk about today. So we might have a problem that looked like, let's say, 3x to the fourth plus 6x cubed minus x squared, all divided by x. So x is the monomial that we're dividing by. So when we have this rational expression, an expression of polynomials that's a fraction, we can take this particular problem and we can simplify it actually into three different problems that make it much, much easier to solve. All right? So if we do that, this is really the culmination of three fractions, isn't it? So with this, I now have something much, much easier to manage. And when I look at that, I just have to do this one at a time. So x divided into x to the fourth. Remember, that is my quotient rule, isn't it? So 3x to the 4 minus 1. I move to the next one, 6x cubed minus 1 minus x squared minus 1 for a final result of 3x cubed plus 6x squared minus x. Okay, so when we just have the monomial in the denominator, we can separate whatever our numerator is into as many problems as there are elements, and then just do each one simply by itself in order to get the final answer. And this works even when I've got a coefficient out here of some number, because then I just divide the numbers by the numbers and the variables by the variables. Okay, so before I actually get into the division with polynomials, we really need to go back to just regular division so that we have that in our minds as to how that process works. So if I were to have the following problem, let's say 1,628, and I wanted to divide that by, let's say, 3. Okay, so I'm going to set this up in the traditional sense of long division. Okay, and I'm going to work this just one piece at a time. Now notice when I do this, I'm asking myself, will 3 go into 1? Obviously, it won't go in evenly. Will 3 go into 16? And it will go in 5 times, because 3 times 5 gives me 15. And then what do? I subtract, right? And I move myself down. So 16 minus 15 is just going to be 1. Once I've done that, I bring down the next digit, and that gives me a 12. And my process starts all over again, doesn't it? How many times does 3 go into 12? Well, it goes 4 times, because 4 times 3 is 12. I subtract again, don't I? And 12 minus 12 is just 0. And so I bring down the next digit, which is 8. And I say, well, 3 times 2 is 6. I subtract again, and I get a remainder of 2. So my answer here is 542 remainder 2, correct? So how can we use this long division process with variables? Well, we're going to find that out right now. We're going to keep this right here so we can see it as our review. And then we're going to create a problem that's dealing with polynomials. So let's get a good example here. And let's say we have 6x squared minus 7x minus 2 all over 2x minus 1. Now, keep in mind that is exactly the same thing as 6x squared minus 7x minus 2 divided by 2x minus 1, okay? So I set this up, 2x minus 1 is what I'm dividing into 6x squared minus 7x minus 2. Now, keep in mind when I was doing this, I'm asking myself how many times does 3 go into 16? When I'm doing polynomial division, I'm asking myself how much this first part of the binomial goes into the first part of what's underneath the division symbol, okay? So how many times will 2x go into 6x squared? So if I write 3x, okay, 3x times 2x, well, that would give me my 6x squared, wouldn't it? So when you're doing this, a little helpful hint is take what you put up on top, 3x, and you multiply it by the entire term that is dividing into, all right? So 3x times 2x is 6x squared. 3x times minus 1 is going to give me this minus 1. Now, here is where probably the most important thing to do in this process. Remember up here when I subtracted? I'm going to subtract again just like before, but now I have to subtract the entire product of these terms here. This is where the mistakes are going to occur. We're going to look at this 6x squared minus 6x squared. We're going to get a 0. But where I see the mistakes are we forget about this negative and we just use whatever is here. But it's negative 7x minus a minus 3x. So that's really plus, isn't it? So what I get here is a minus 4x. Now, just like before, I bring down that next term. And I start the process all over again. How many times will 2x go into just this first part? Well, what if I put a minus 2 here? So I'm going to come over here and I'm going to say minus 2 times 2x minus 1. So I can really see what it is that I'm doing. Minus 2 times 2x, that gives me my minus 4x, right? And that's the important thing. I want to make this term match what's above. This term match what's above because I need it to subtract out to 0. And I'll look at the rest of it. Minus 2 times minus 1 is going to be a plus 2. And then, just like before, I subtract my result. Minus 4. This is plus 4, so that's going to be my 0. Here I'm going to have minus 2, or minus 4, all right? And when I look at this, I now say that my answer is 3x minus 2 with a remainder of minus 4. Now there's a different way of writing this now, what we're doing with polynomials. We want to say it's 3x minus 2 plus my remainder minus 4 over what I am dividing in, okay? So I could have pulled the minus out and had to subtract this, but this is my form. My answer plus the remainder over what I am dividing in, okay? So this time I got a remainder. We won't always get a remainder. So let's do one more, and we'll kind of bump up the ante, if you will, on the complexity. Let's say we had x to the 4th plus 9x squared minus 3x plus 5, and we're going to divide in x squared minus x plus 2, okay? So we'll set our division up, x squared minus x plus 2 into x to the 4th. Now, notice this particular polynomial did not have an x cubed term, did it? So in order to keep our math easier, we like things to line up. Let's say we have 0 x cubes in there, okay? And you'll see why in a minute, why it's important to have this placeholder, because 0 times anything is still 0. So I haven't changed my numerator, but I'm going to make my math a whole lot easier. So plus 9x squared minus 3x plus 5. And now I can start my process. Now it looks bad, but it's not. The process stays the same. How many times will x squared go into x to the 4th? That's all I care about. I don't care about the rest of this term right now. So x squared will go into x to the 4th, x squared times 1, because bases are the same. You add the exponents. And so over here, I'm going to have x squared times x squared minus x plus 2. And I just have to multiply this out and put it over here. So I'll have x to the 4th, which is important that they're the same. X squared times minus x is minus x cubed. X squared times 2 is plus 2x squared. And remember my process. I'm going to subtract this entire result. When I subtract x to the 4th from x to the 4th, I get a 0, which is what I expected. Now you see why it was so important to have this placeholder, because I can line my x cubes up and do my math to get an answer down here. So 0x cubed minus a minus, or plus, gives me plus x cubed, doesn't it? Then 9x squared minus 2x squared gives me plus 7x squared, okay? So process stays the same. I bring down the next term, and I start all over again. What times x squared gives me x cubed? Well, won't that be an x? So x times x squared minus x plus 2. This is going to give me my x cubed. X times minus x is minus x squared. And x times 2 is going to give me plus 2x, right? And so I want to draw my parentheses here so I can clearly see I'm subtracting everything. This gives me a 0 as I expected. Then I have 7 minus a minus, so that's a plus. I get 8x squared minus 3 minus positive 2. That's going to be minus 5x. And then I'm going to bring down my last term here, plus 5. And I'm going to ask myself, what do I multiply x squared by to get 8x squared? Well, that's simply going to be plus 8, isn't it? So I'm going to write down my work here, x squared minus x plus 2. So 8 times 8x squared is 8x squared. 8 times minus x minus 8x. And then 8 times 2 is 16. So I'm going to subtract like before. This better be 0 or I've picked the wrong multiplier. Then I have minus 5 minus a minus 8. So I'm going to be adding 8 to minus 5. I'm going to get 3x. And then I'm going to take 5 and I'm going to subtract 16. And so that better be minus 11. So my answer becomes x squared plus x plus 8. And I could say remainder 3x minus 11, but we want to get in the habit of writing this the appropriate way. 3x minus 11 all over x squared minus x plus 2. So notice I'm consistent in my notation all the way down. Look how my answer gets formed with what my little notations are here over on the side, right? X squared plus x plus 8 down here. So that's how I'm going to do polynomial division. So what did we do today? Well, we started off dividing by a monomial, and this really is just multiple fractions that have all been, condensed into one term, so I can spread them out and do the simple math versus trying to work with this larger term to get my answer, okay? And then we just went in and we did our examples. And again, all we're trying to do with this number up here is multiply by the first part of the term to match with the first term that's under the division symbol. It needs to subtract out to 0 or I've picked the wrong term. And again, my answer gets formed from my notation over here. And of course, we want to always take our remainder and place it on top of what we're dividing, okay? So that concludes our lesson on division with polynomials, and I will see you guys next lesson.